Hello everyone, I'm Aman and I'm a research engineer at Facebook AI Research. Today I'm going to talk about our research framework MMF, which stands for a multimodal framework, which is used both for research and production inside Facebook. And I will specifically talk about how you can use them into your vision and language research. Before we even dive in further, let's talk about what do we mean by vision and language tasks. Here in specifically in MMF's language, any task that involves a visual and textual component and requires reasoning over both to solve it, we would call it a vision and language task. So let's say we have an image and text source which is passed through model. Model does its voodoo magic and runs back an output. This is a scenario we will be limiting vision and language tasks inside MMF. So anything that fits inside this particular scenario is a vision and language task for MMF. Specifically, we are not concerned about video tasks here. We are only concerned about image-based tasks here. We are planning to add video tasks sooner or later inside MMF. So keep an eye out for that. So let's first talk about an example of vision and language tasks before we dive in further. So vision question answering involves answering a question that's about an image. And text VQA is a variant of VQA where it involves answering the question, but the question requires reading text in the image to answer that. So let's take an example of VQA task. We have an image and a question that is basically about that image. Zooming into the image, we can see that we require reading text in this image to answer the question, or you can see where exactly the cars are to see whether the left lane is closed or not, or right lane is closed. So the model takes in both image and text, does reasoning over it, and should return back left. The another task that is involved is very popular in vision and language domain is image captioning, where we take in an image, pass it through the model, and generate a caption based on the image. Text capture is a variation of image captioning similar to text VQ, but which requires reading text in the image to generate the description. Then we have integrity classification tasks such as hateful memes, which takes in an image where you can see there's a meme which says, look how many people love you, and there are a lot of people inside this image, which basically means that this is not hateful. So the model takes in both image as well as a text inside the image and classifies it as not hateful. MF contains variety of these tasks which are divided into different domains. These domains are by no means like restrictive, so one task can be in like multiple domains like SNIVI can be integrity classification as well as reasoning. Same for visual question answering. It can be inside VQ as well as reasoning. So we have like various kind of tasks from visual question answering, image captioning to dialogue and integrity classification inside MMF. And we keep on adding new and new tasks every day inside MMFs. So MMF is our multimodal framework which we have built from scratch based on PyTorch for fast vision and language research. So MMF was used to call Pythia, which many of you might know about. So we have rebranded Pythia as MMF now. M- Moving from Pythia to MMF, we have made a lot of performance improvements. The same M4C model which used to take around 16 hours to train on 8 GPUs now takes only like 5 hours to train on the same amount of infra and compute. So we have made 3.5x percent improvements inside MMF speed when moving from Pythia version 0.3 to the current MMF. So why do you want to use MMF? What are the major reasons why would you want to use MMFs? So first of all, MMF involves less boilerplate. So what do you mean by that? So running a distributive fine tuning from a pre-trained model on two nodes from a SOTA model just involves this much of code, like specifying what's your world size, which config which you want to run on, the dataset model, and which particular zoo model you want to resume from. You have to only specify these many options. Everything is configurable, so everything from distributed support to configuration to checkpointing to early stopping has been already configured to you. So let's go through some examples of what exactly we have in the boilerplate. You don't need to write this again and again, and MMF will provide you out of the box. So common metrics analysis used in VQA or like vision and language tasks, something like blue, VQA accuracy or something else. Then the distributed trainer, we provide a lot of SOTA models, pre-trained models which you can just directly import from MMF and download them and use them directly. We provide automatic downloads for the dataset. We run the command, dataset is automatic download for you, and then you can go on with your main thing. So, and then we also provide pre-training, fine-tuning approach, like you can pre-train a model, then you can take specific parts from that model and fine-tune them. Then you can do hyperparameter optimizations. You can launch large sweeps and it's very configurable. We have a lot of V&L encoders and modules which you can use out of the box and plug in them into your model, try different encoders, see how they work with your system. Then we also have V&L optimizers and schedulers customized for our use cases as well as regular V&L use cases. So you can also like add your own optimizer schedulers and there's a lot of things. So using MF, we want you to focus on what matters most. That's your model and we will take care of the rest. Like you don't need to set up all these things, all the boilerplate code again and again. You can only focus on your model, rest we handle for you. MMF is powered by PyTorch, which means you can basically use everything that you know about PyTorch inside MMF. You can create your PyTorch based data sets, you can do models, you can use all the PyTorch modules and whatever you want. So powering by using PyTorch, we leverage everything that PyTorch provides inside MMF. So all of the components in MMF are PyTorch powered. Even basic modules and everything else is written from scratch using PyTorch. So you can extend them, use all your PyTorch knowledge, basically use them however you would like. So third thing is that MMF is modular and composable as well as easily extensible. So what do we mean by that? So MMF has like a registry system where you can register your custom models, use basically this allows you to like use MMF as a library. You can pip install the package, then use the registry system to let MMF know about your model, and then MMF will load your model, use MMF trainer. This will allow you to write custom libraries independent of MMF. So you can register your custom model, you can register your custom dataset, you can register your custom processor, you can register optimizer, loss, trainer, metrics, and a lot of. So MMF is like configurable from ground up, so you can override everything, you can implement all how you want using whatever MMF provides wherever you need. So that allows it to be very modular as well as configurable. So we have designed MMF from scratch in a way that people can easily use it however they like. Let's dive into some specific details of how you can use MMF in your custom projects and how MMF handles various things and how do models and datasets work inside MMF. So let's take some specific examples again. So for question answering, you have a image and a text. The text is the and then you pass this through processors. So you can think of processors as torch vision transforms, which takes in an input and returns an output. So this key allows us to keep our dataset modular while reusing the same code in different datasets. So all this is like configured from configuration system. Like there's a text processor. If you want to use uh, glove, then you say that I want glove text processor. If you want to use BERT encoder, you say you want BERT text encoder. Similarly, for image, you can like specify all the transforms you want for fast text, which whatever kind of embeddings you want. So these go to the processor. You get back a sample. Sample is a custom object inside MMF, which represents a single element from the dataset. These sample combine and like get converted into sample list. So sample list is like a wrapper over batch which allows easy access to different kind of attributes inside batch. This allows us to like decouple dataset from models. So datasets return back a sample list and models take in a sample list. So this allows us to use multiple datasets with multiple models and have a decoupling structure between them. So let's see how we can connect these datasets to the MMF model. So let's again take an example of VQA that we took in start. So there can be cases like in this one, like you can have OCR tags, which are like other modalities, which are not the common thing inside a data set, something like OCR or something like face features or something like other embeddings which you don't normally use, but this can be other modalities. So image goes through an image encoder, which can be of different types and is configurable. So it can be ResNet, ResNext, faster RCN, or something else. Similarly, for text, you have text encoder, which can be many times. For example, you can use BERT, Robota, Glove, FastText, LX, LMR, or anything that Hugging Face Transformer provides. We have a dependency on Hugging Face Transformer, which you can use, which allows you to use anything from that package. And these are all configurable through config system of ML. Then similarly for other modalities, you will have a particular modality encoder, which can be something specific to that modality. For example, for fast text, you can have different kind of encoders which convert them into fast text word vectors to sentence vector. You can do something with it. So all these modalities pass go through a encoder and get back a representation, which is passed through some kind of fusion mechanism to return back a single embedding. So these fusion encoders can be also of different time. For example, recent vision and language model involves transformers, something like Wilbert, VisualBert, or something else. Then late fusion models, element-wise models, which basically take element-wise product of the encodings to generate a final embedding. Then it can be MCV, or you can use attention-based fusion, like the older Pythia-based model. So finally, once you have the fusion, you pass it through multiple kind of heads, and these heads gives out an output or loss which you can use to back propagate through a whole thing. So let's take some specific task examples to understand what exactly we mean here. So visual question answering will have a classification head which will basically generate. Then we have visual entailment, which again has a classification head. And the task involves an image and a text, and you have to tell whether the text is like entailment, contradiction, or neutral with respect to the image. So you have three-way classification, and the classification head is configurable for number of classes you want to output. So in this case, like there is a bread shop on the left of the road, and it's actually on the right side of the road. So it's a contradiction here. Uh, Then for image captioning, you can similarly have a generation head which generates some kind of text. For in this case, particularly takes in an image and returns back a. Similarly for integrity classification, you can take text and image and again pass it through classification head and do two-way classification of hateful and not hateful. And let's see how exactly we can do pre-training fine-tuning inside MMF, which is like a very major use case in current vision and language scenario, given all the recent inundation of uh, multiple transformer-based vision and language models like Wilbert, VisualBot, and others. So you can take in like, for example, mask language pre-training, where you mask a word and you have to predict vector word. So you will just apply a pre-training head on top and predict the mask token that's left. So you can similarly calculate the loss here and just back propagate through the whole one. So you can take the part that's before pre-training head and just copy paste it inside here for video question answering, add a classification head on top. So replacing this head is very easy inside Python. You just specify your pre-trained state mapping and you you can just get the same thing back. So on the side, I show how it's possible through the configuration system. In checkpoint, you say that this is my resume file, like this, the pre-trained file. the pre-trained file checkpoint, and then you say I'm resuming a pre-trained model, and then I specify the pre-trained space mapping which maps model to model, so it won't load the head. So after learning through this, it will start classifying this question's answer as. So the overall end-to-end flow of MMF is like you take in an image and text, pass it through the model, and then you have like different kind of heads on top, which you can replace, and then you can use the same pipeline again and again by using pre-training and fine-tuning. So this allows us to do multitasking inside MMF. Um, you can you can pass in through multiple data sets inside MMF through the same model, and they can all use their own head. And this way we allow multitasking inside MMF, which is an interesting feature for future use case. So in models inside MMF belong to multiple categories. We have a lot of models inside MMF. So they can be like multimodal transformers like Visual Word, Wilbert, Pixel Word, and MMBT, then dynamic answer space models like LoRa and M4C, which are specifically useful for text VQA kind of problems where they point to some dynamic answer space. So this tells us like there can be like very different type of models, which tells again about like how flexible MMF is with regard to your model. Like we make no assumptions about your model, so you can ideally do anything you want. Late fusion, unimodal, attention fusion based model that are older Python based model, and then also the database models. So possibilities are endless. So then once you are like done with your project and you want to publish your pre-trained model, we already provide a lot of pre-trained models inside MMF. So you can just do this 3-line code for classifying some URL and text into hits. So an important thing inside MMF is MMF's configuration system, which allows MMF to be as configurable as it is right now. So it's important to like have a look at it, like how exactly we do configuration inside MMF. So there is like a default configuration inside MMF which provides basic defaults for everything inside MMF. For example, training something like snapshot interval, log interval, maximum updates, batch size, checkpoint. How do you exactly want to resume? Do you want to resume from pre-trained file, zoo, or something else, then distributed setup, then scheduler attributes, and a lot of different things. So this is like a base of our configuration. So our configuration system is Omega conf based, which is what Hydra is based upon. So it's very configurable in the sense that it allows you to do various kind of things with YAML files, includes and other things. So then after the default configuration, we have per dataset and model configuration, which defines the defaults for that particular model or that particular dataset. For example, here for MMBT, we have defined the hidden size as 768, num layers as 12, and dropout as 0.1. Same for datasets, you can define where the features are. And then these configurations are used by the dataset and model builders to build the model in the way the user wants. So this is all very configurable. So the user can configure based on their particular experiment. They can configure all of these defaults and update them based on their own parameters. Let's say I have a particular version of MMBT where I'm using hidden size of 1024 and I want a base size of 32. I will fix this inside my configuration, and that will be my experiments configuration, which I can distribute with other users so that they can replicate the same setup as me. Then for running parameter sweeps, everything is configurable through command line ops. So you can basically pass training.batch size equal to 64. That will update the user configuration and all of the configurations before to have the batch size 64. And then you also specify dataset and model here, and then you can use the mmf underscore run command to run this. So this allows us to run hyperparameter optimization at a large scale. So for example, you want to like do a grid search over batch size in LR. So values of the batch size lie between 1512 and 1024, and LR lies between 1e minus 5 and 5e minus 5. So it will run a grid search over all four by passing them as a command line argument and overriding whatever it requires. So we have uh, grid search and hyperparameter optimization utilities inside MMF, including visualization utilities that can help you maintain, launch, and maintain experiments at very large. MMF is made for scale. This is very evident from the recent archive report from our group, where we conducted 500 plus experiment easily, each on 32 GPUs. As you can see the table, there are so many combinations that each have been run through a very extensive hyperparameter sweep to get the best values out of it. So, and the models are very big, including Visualbot and Wilbert. So we were easy able to conduct more than 500 experiments on 32 GPUs using MMF without any hiccups. So MMF is made for scale. Feel free to use it like for any kind of experiments that you want to use. We provide all these hyperparameter scripts inside the package itself. So there are endless possibilities using MMF. These are all the projects that were done inside here using MMF, or the projects whose implementation has been included inside MMF. And MMS has like made it possible to make do very different kind of projects easily. Like M4C and Hateful Memes are very different kind of projects which are easy done and live in the same code base based on the configurable approach that we have with MMF. So MMF made a lot of projects possible, and we hope that you will use MMF for your own project as well in future. So we are looking for the community contributions, and we are always open for any kind of contributions that community wants to do. If you want to use your favorite model inside MMF, like feel free to like open up a PR, and we can also help you to land that PR inside MMF. So MMF is possible due to a joint collaboration between a lot of teams and folks. This includes but not limited to the people listed here. So this has been like a very joint big effort inside Facebook, and this is being used in production as well as research settings. So here are the resources that you can follow if you want to learn more about MMF. Looking forward for you to use MMF in your next project and any feedback that you have regarding that. Thank you.